All right, so we have talked about what happens when x is in the denominator, but let's look in more detail at the situation when I have square root. So we're talking only about real numbers right now. So that means that what's underneath my radical needs to be greater than or equal to 0. And this has a specific name. This is called our radicand. That's what's under the square root. So we're saying that our radicand needs to be greater than or equal to 0. So if I had something like x minus 3, my domain would be when x minus 3 is greater than or equal to 0. And then if I think about a number line, we have 3. I can equal it, so filled in circle. Greater than is going to the right. So interval notation of this would be straight bracket 3 to infinity. When we do these restrictions, this is so important. We do it from the unsimplified equation. The unsimplified equation. Sometimes my square root will cancel when you simplify, but it doesn't matter. If I can't plug it into my earlier function, then I can't plug it into the final function. So here's what this is going to look like. Let's add some color coding. Wonderful. Okay, so we're going to do h of j of x. So my big function is going to be 2 times something minus 7, and the something we're plugging in is square root of x minus 5, so that's my final answer. But now I see I have a square root. So I need to take the radicand, x minus 5, and I need that to be greater than or equal to 0. X needs to be greater than or equal to 5. If you need a number line, here's what that looks like. So my domain is 5 to infinity. This means I can plug in any numbers from 5 to infinity to my final answer right there. Let's go a different way. Let's do j of h of x. So my outside function is j now. Square root of something minus 5. And we're going to plug in 2x minus 7. That's my final answer, but I can't plug in every number I want. I have to take the radicand, what's underneath the square root, and it needs to be greater than or equal to 0. Combine like terms and solve your equation. I get x needs to be greater than or equal to 6, which in interval notation is 6 to infinity. Last one, g of j of x. So my big outer function is something squared plus 1, square root of x minus 5. That's my final answer. But I have a square root. So that means what's under the square root, the radicand, has to be greater than or equal to 0. So x needs to be greater than or equal to 5. But Miss Vance, wouldn't the square root and the squared cancel? Yes, they would in the simplified version. But since I can't plug in anything less than 5 into j of x, I can't plug anything less than 5 into g of j of x. So just because it looks like it disappears, that domain restriction is still getting held onto in my final composition.